Hello everyone. In this video, we are going to discuss the numerical 2 from your very first chapter, that is vector algebra. And if you look out for that, your numerical 2, so we are given with the 3 points that we have written over here. That is point P having the coordinates 1, minus 3 and 5. Then we have the point Q having coordinates 2, 4 and 6. And we have the point R having the coordinates 0, 3 and 8. So very firstly, we are going to write the position vector for your respective points, that is point P, Q and R. So what exact is the position vector? So position vector is nothing but the distance in between the origin and your given point. So say for now we are given with some coordinate system. Okay, fine. We have the origin over here and we have the point P over here. So the distance in between that origin and point P is going to give you the position vector. And for your coming lectures, whatever the position vector, I am going to rewrite it as I am going to represent it by using this word, that is PV. So PV is nothing but what for our coming lectures. So that is the position vector. Okay, so this is what is the concept of the position vector. You can go through the book for the same. Now, what is the position? So since we are given with the point P, so what will be the position vector for your point P? So position vector of your given point P is represented. I am going to represent it by using this vector RP, small vector RP. So that indicates you what? Position vector for your given point. And what is the position vector for your point P? So that will be simply the 1 minus 3, 5, that will be representing you the magnitudes, or you can say the components along the x, y and z direction. So what will be the position vector for your point P? So very firstly, what is the magnitude, or you can say the component along that x direction? So that we have to be 1 over here. So that will be x. Then what is the magnitude along that y direction? So we have that to be the minus of 3 ay. And what is the component or magnitude along z direction? So that is what is plus of 5az. So this is what we have the vector rp, or you can say the position vector for your given point P. Now in a similar fashion, we can go with the position vector for your points Q and for your point R. So till I write it down, you can go through that position vectors, and let's check whether you are right or not. Now what will be the position vector for your point Q? So position vector for your point Q will be what now? That is component along x direction. So that is 2 ax cap, then component along y direction, that is 4 ay, and then component along z direction. So that we have to be 6az. Now what is the position vector for your point R? So that is we have the 0 along x direction. For your simplification purpose, I am writing it down. If you have enough practice, you can skip that one. Then component along y is what? 3, and component along your z direction. So that is what? 8 times of az. So these are the 3 position vectors that we have. Now we will move on to the very first part of the numerical, where we have to find out the position vectors for point P and point R. So I guess I have written it over here. So there is no need to rewrite it again. That will save your time. So the position vectors for point P. So position vector for your point P is what we have, that we have written over here. So this is what is the position vector for your point P. So answer is what we have, that position vector for your point P is ax minus 3ay plus 5az. And next is what is the position vector for your point R. So what is the position vector for your point R? So this is what we have. So position vector of your given point R is what? 0ax plus 3ay plus az, or you can write it in this fashion as well. So your position vector of point R is equals to 3ay plus AZ. Both answers are acceptable. Okay, so you can go with this one or you can go with this one as well. Okay, fine. So this is the very first part that we have done. Now we will move on to the second part of the numerical where we have to find out what is the distance vector RQR. Sorry, this one. Distance vector RQR. So in part B, we are going to find out what is the distance vector RQR. So distance vector is what? It is the distance in between the given 2 points. So what are the given 2 points over here? We have the point Q and we have the point R. Okay, so whenever we are talking about the distance vector, say this is your coordinate system for now. Just if you are new to this one, I'm explaining it, or you can skip that part as well. Say for now you are given with the Cartesian coordinate system where we have that x, y, and z. So at some place, say this is your vector q, sorry, point q, and this is your point r. So we have to find out what is the distance in between that q and r. So here in this case, what is your final point? See, whenever we are talking about the distance vector or distance in between the two vectors, we have to consider what is the initial point and what is the final point. Since we are given with the vector RQR, so here in this case, this R point or position vector of your given point R will be the final one, and Q will be what now? Q will be the initial one. So always we have to subtract this initial from your final. Well, I hope you have got the concept. So this point R is your final point and this Q is your initial point where your vector is going to start from this point Q to point R. Okay, so we will find that distance vector for this numerical. So your distance vector RQR is what? That will be the distance in between the final point, that is vector R, and its initial point, that is vector Q. So what is the position vector for your given vector R that we have over here? You can refer this one. So we have that value to be 0, ax plus 3 ay plus 8 az. So this is your position vector for your point R, and then we have to subtract the position vector for your point Q. So you can refer this one over here. So what is the position vector of point Q? So that is 2ax plus 4ay plus 6az. So this is your distance vector. So the difference in between that two, it will give you the distance vector RQR. So component by component we have to subtract that one. So 0 minus 2 will be what now? That will be minus of 2ax, sorry. So that will be minus of 2ax. 3 minus 4 will be what now? That will be minus of ay, and 8 minus 6. So that will be what now? 8 minus 6 is plus 2 az. So this is what? This is your distance vector RQR. Okay, so this is the answer for your part B of the numerical. Now in the third part of the same numerical, we have to find out what is the distance in between Q and R. Okay, so distance in between Q and R. See, whatever that we have found out in part B was the distance vector, and in part C of the same numerical we have to find out what is the distance in between Q and R. So distance in between Q and R is nothing but what? It will be the magnitude. Always keep in mind, whenever they have asked you to find out the distance in between any of the two vectors, simply we have to find out the magnitude of the given vector in between the two position vectors. Okay, so we will go with the C part of the numerical. So the distance in between Q and R will be given by means of the magnitude of your given vector, that is vector RQR, that we have just found out in this part B of the numerical. So magnitude is given by means of what? So that is square root of this minus 2 square, this component along y is what? Minus 1, that we have minus 1 square, plus this component along z, so that is 2, so 2 square. So minus 2 square plus minus of 1 square plus 2 square. So if you simplify that one, you will have that to be the square root of 9. And what is the distance in between that two points, that is vector q and vector r, position vector q and position vector r? So we have that magnitude of your given vector rqr is equals to 3. So this is your final answer for part C of the numerical. Okay, we are done with the numerical 2. If you like this video, if you want to appreciate my efforts, you can hit the like button. Okay, thank you.